Hello everyone. Happy r/roguelike dev does the entire roguelike tutorial 2025. I've put this off for over a whole year, so I'm going to run you guys through the McRogueFace first three parts of my tutorial for using my engine. So for part 0, we're not going to do anything except for set up a tile grid. In TCOD, you would probably do this with ASCII characters, but McRogueFace is basically focusing on making sprites available. So we are going to take this tile sheet and make this grid area with trees around the outside. So it's only 80 lines of code. Basically what you'll do is you'll import the libraries you need. You will create a scene. McRogueFace is entirely scene-based, so if you create a scene with some name, you can put a bunch of UI elements and grids with tiles on it, and switch to another scene, switch back. All that stuff will still be where you left it. So first thing we're going to do is load a texture, and this file is a sprite sheet that contains 16 by 16 pixel tiles. So McRogueFace will support any tile size you want. All the tiles do have to be the same size, but they don't have to be square. You can have rectangular tiles if you want, so that could mean McRogueFace could be hacked into doing isometric projection or something like that, but I'm not even going to touch that yet. For now, let's just stick with top-down square tiles. So you may be tempted to do a bit of math about how large your grid will actually be. If you make your grid on screen smaller than its actual contents, there are ways to move the camera around and show a different subsection there. So when we make our grid, you can see that the grid has, I've calculated the size so that the entire grid fits on screen. That's not strictly necessary, but it is nice if that's your intention for your game. If you have like a 25 by 20 grid like we're about to make, then you can make that entire grid fit on screen. So we're going to create this grid by instantiating the grid class. We're going to tell it how many tiles are on it, and we're also going to tell it where on the screen this is. So I've calculated based on the size to center the grid. You can see that the green area here where the trees and grass are, that's the size of our grid UI widget. And it's positioned away from the corner of the screen, which centers it on the screen. This is how you can put captions or other UI elements around it, or even on top of it, and they'll get the click events if they're on top of it if you put stuff stacked up. Here, I'm going to define some different tile types. So when I say floor and give it these numbers, we're actually looking at that sprite sheet. Let me open up this sprite sheet. So this is the sprite sheet. There's almost nothing to it. You can see I have some variations of trees, which you can tell by that kind of the one corner there that one tree is flipped around. It's just some minor visual variation. Same thing with the grass. So this is our tile sheet, and in McRogueFace, tiles are done by index. So this first all green tile, 16 by 16 pixels, would be number 0. And since this sheet has 12 tiles, it will go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the 11 tiles, or the 12 tiles numbered 0 through 11, you reference that number, and that's the tile you'll place there. So when I set up these numbers, I'm just giving Python an opportunity to know this is all the floors, randomly pick one. This is all the walls, randomly pick one, to display whether or not a square is walkable or not. So in McRogueFace, we can set the tile index, the tile sprite of any point at the grid. So grid.at will give us an object that represents that particular tile of the grid, and we can set the tile sprite. We can also set it to walkable or transparent, which we'll use later on. Those are properties used to create a T-cod map for field of view and pathfinding. But for part 0, we're just putting some tiles down, right? There's also captions. This is like putting text in T-cod, but you also have the option to change the color, give it an outline, change the thickness of the outline, change the font size, and position it at different places. And when we get to animations later on, you'll be able to animate the size, color, position of your fonts, your captions. So that is it for part 0. If there's a seg fault, don't worry about it. McRogueFace is still in alpha. Let's go on to part 1. So in this tutorial, we're going to take the same basis for showing a grid, and we're going to add the ability to put keyboard input and move this little dude around. So the little dude is on a separate sprite sheet, but he's moving on that same grid. There's no collision detection yet. You can walk on top of the trees. You can walk off the grid and out of view. Nothing unusual about that. So, McRogueFace supports resizing now, so you should be able to make this look nice and big if you like that sort of thing. So let's look at the code for part 1. A lot of it's going to be exactly the same. We've only gone up to 116 lines of code, and we haven't modified the grid at all. You can see it's just displayed exactly the same way. What we've created is an entity, and in McRogueFace, an entity is an object that lives on the grid. You can just use it directly, and it basically is a sprite that can move around a grid. There's more hot new features coming up with this, but something that works right now is you can make a subclass of entity, and you give that entity to the grid to render, but you can put all of your game logic into your custom extension of the class. Now, the way you use keyboard input in McRogueFace is you set up a function. I usually call mine handle keys or keyboard input, something like that. This is going to give you callbacks whenever there is a key event with these two fields. Key is just going to be a string like W or up that represents the keyboard key that was pressed. And state is going to be the string start or end, which represents if the key was pressed down or if the key was released up. So if someone presses and holds down a key, you'll get multiple start events in a row. That's just from the keyboard repeating. So we tell McRogueFace that whatever the active scene is, when you get a keyboard input, please call the key handler function. And that's basically it for this tutorial. Now that we have instructed McRogueFace to call this function, it is going to see that the entity's on the grid, and it is going to change the entity's properties whenever there's a key event, and that allows you to press keys and see the little guy move. You can imagine that this is the right spot, or a right spot, to implement checking if the tile is walkable or not, or checking if it's a tree versus grass before you allow the player to walk there. Okay, so what we're going to add on, this is like a little bit past the week 0, week 1 stuff that the T-cod tutorial is doing, but I'll just keep showing what I've got right now. We've got part 1b. So what I've done in this demo is it's almost exactly the same demo as before, but now when we walk, we are going to change the center of the grid to stay centered on top of the player entity. So if you move this guy around, even if you move him off the edge of the grid into, coordinates that are out of the bounds for the grid, there's nothing stopping an entity from being at any position in relation to its grid, even if there are no tiles there. So that can cause undefined behavior. You would not be able to pathfind if you're outside of the grid. There's no information about tiles that don't exist. But you can put your entities there. It's just a position to draw them. So the way we do this is a pretty simple change. The main thing is that I zoomed in the grid to 3.0, and that means that a 16 by 16 pixel tile is now going to be 48 pixels wide. McRogueFace kind of leans into that simple pixelated look. So once we zoom in, now the grid is going to be closer to the tiles, or we're going to have larger tiles. The only thing we have to do to adjust that is just know when you zoom in more, the whole grid is no longer visible. The only thing we're going to do is center the grid on the player's position after we move them. So a complication here to think about is that the coordinate for a tile is kind of like the top left corner of that particular tile. So if you want the camera to be really centered on a square, you have to add half a tile to it, and that's times the size of your actual grid's pixel size. I'm thinking that the camera is going to be measured in fractional tile coordinates instead of pixel-sized coordinates, but that's just a minor thing I'm toying with. It's not a breaking change to the behavior. So that's all working. What I think I'll show next is I have a part 2, and the only thing I've really added with this one is I've added animation. So let me just zoom in this a little bit, and what we can see is that the character is now taking like 0.15 seconds to complete his move to each square, and this kind of, it limits the speed that you're going, but it also kind of gives it a little bit more visual flair. No changes in rules in terms of collision there, but now we're able to walk around, and what you see up at the top with all that debug information is that we can tell when there is an animation running in McRogueFace, and we can just say that, like, if the animation is running, don't accept another command. But that actually makes the input very unresponsive, because you press a key, the animation finishes, and the character does not do the move that you tried to tell it to do. So in this movement tutorial, I have added a cue for a single key press, and that means that if you put in multiple key presses, the one next key press, which you can overwrite if you keep pressing different keys, but just one additional key press is going to be in the queue, and as soon as the animation finishes, it will attempt to make the next motion in progress. So what that gets you is a kind of quick and easy way to make the player continuously move when you hold down a button, even if it's animated, and you get a more or less reliable or satisfying feeling of whenever you stop pressing, you haven't queued up 1,000 actions that take forever to animate and you have no way of canceling. You just get one additional move that kind of keeps things moving and also lets you kind of walk pretty reliably in a diagonal. And if you actually press the keys at a normal speed, you can get a pretty decent normal looking result out of there. But you can also mash buttons and you'll get a little bit of a random, slightly random which key actually gets queued up there. So I think that's kind of like, I think this is like the core of McRogueFace's aesthetic. I really wanted to be able to just start slapping together an idea with tiles from a tile sheet instead of with ASCII characters. So none of the stuff is ready for the rest of the tutorial. I'll be following along, trying to stay slightly ahead of the tutorial series with r/roguelikedev this year. But that's basically the idea, and I'll get into pathfinding, field of view, world generation, all that stuff right along with you guys. McRogueFace runs libtcod under the hood, so there's nothing libtcod can do that McRogueFace can't do. I'm just trying to add this slightly more modernized sprite-based graphics to it to just satisfy the slight bit of eye candy that I want out of a video game. So thanks for watching. and see you in the next one.